Today I want to give a little bit of a twist into more the technical side. It will be a mix of talking about the building track of OWASP and the attacker or tester side of OWASP. So today we are going to go on our race. That's why I said get ready for your race. And as I saw that here in the neighborhood, the countries, you use a lot of QR codes. Let's see. Probably it's time to show you one. If you can scan it, it's just a simple survey so that we can start looking at something together. Nothing too difficult. So this is the question that we are going to answer. Oh. Let's see. Okay, it's good we have a lot of yes. It's also nice we have a few no's. That's even nicer. So keep that on your phone. It will come back later. Oh, I need to see the right side. Okay, that's good. So now, who am I? I'm the guy in the picture, and even the guy who is talking to you now. And I am a security researcher at Veracode. I've been working in this field for a few years now. I've been doing penetration testing and ethical hacking. And before joining my current company, I was working in a bank as a security manager in a bank. So I have a background in different languages, Java, .NET, Golang, PHP. And this is mainly the focus of my research in Veracode. So, and the reason why I started this topic, and I thought it could be interesting to bring it back, is because racing conditions seems that many people think they are just a thing of the past, something that you can have only on an application that is written in C, C++, probably COBOL, but yeah, who knows. So, but in reality, that is something you may find even in modern application, as we are going to see soon. So this is the agenda for today's talk. I'm going to give you a bit of history of race conditions are, what they are, where they happen in very interesting places where you can find them in your day-to-day life, and where you may find them in an application you may be testing or developing yourself. So then, I think the fun part, if everything will work, will be a live demo of a real-life race condition that I'm trying to exploit in real time, and show you a few tools to replicate that. At the end, the repository will be shared on GitLab, so you will be able to play and use it. So this is a little bit of introduction to race conditions. Usually race condition happens when you have a shared resource, and that resource is used for different purposes or for the same purposes but by different actors. By actors, I mean it can be a thread, it can be a process, or it can be even two different applications that are sharing the same file. So in that case, there may be a condition for race condition. So, and as I was saying, that's not something you cannot find in a modern application, and that's something you find every day, most of the time, but you don't realize that there may be one because the application or software or device we are using is limited in the number of users that are using it at the same time. So that makes maybe a sort of mitigation for the race condition to happen. So, go next. So, a bit of history. I don't know if any of you have heard of this Therac 25, but it's said one of the worst bug in history when an MRI machine was controlled using the same variable, and the same variable was used to manage the user input into the device, and at the same time to measure the radiation given to the patient. If you were typing too fast and the two processes didn't have time to switch properly, you may be killing your patient. As that happened, 3 persons died because of a race condition. So have a look. This is an interesting history into software security. So then, vending machine. How many of you have tried, maybe when you were younger, to push 2 buttons at the same time, hoping to get the most expensive item, paying for the less one? So that's one case of race condition, or as it can be said, time to use, time to check. So that's another case. Or redeeming multiple coupons. This is something that sometimes penetration testers find when they test web applications that deal with cards. So if you are fast enough, and this is what I'm going to demonstrate, you may be able to pass 2 times the same coupons. So you may be able to get twice the discount by using the same coupon. Okay, so I think we're going to reach the end of the introduction. This is a few ways or places where you can find race condition. They are categorized with different CWEs, as you can see, and they depend. The underlying issue is often the same race condition, but then it can manifest in different ways depending on where the race condition happens. So time to check against time to use is when you are checking a variable, then something happens, and then you do your action without checking the variable again. So that's what talk to is. Otherwise, session puzzling is something similar. It's also explained pretty well in the OWASP website. And it is when you have a variable that is used for 2 different purposes in the same application. And that variable is maintained in session. So depending on when you are checking the variable, your application may behave differently. So you may be able to work as an administrator even though you are a guest user. And then deadlock, who I think when I was studying my computer science courses, I was scared of deadlock because I was thinking, when that happens, I can't do anything else. And race condition may manifest as a deadlock too, depending on what the race condition is, in which part of your application it is. So, talking about coupons, now it's time for the demo god to do something for me. So let's see. So I made this little basket application. It's very basic, so just to demonstrate what we're going to do, and I registered that with this website. That probably is going to work. Yeah, it's working, but on my laptop, on my screen. Is it? Here we go. As you can imagine, I'm not paying much for the hosting. Yeah, not that. Okay, but I have a local demo so that it works. Just trust me, it's the same. It is. Okay. So this is what you do. You have your shopping cart ready. So this is what happens when you have the right coupon. But let's say we don't have a coupon. So this is the basket value. Then we enter a random coupon. Nothing happens. Then you enter the right coupon. Let's see. Yeah. Oops. It's not very comfortable this way. Click. Here you go. Yes. So, and this is what happens. As you see, in this application, you can't use the same coupon twice. But now we will try. So I think most of you, at least the one who said maybe that know what race condition are, they also know what burp is. I think, sorry, I should have used Zap proxy next time. Sorry, yeah. Sorry, I realize now. Sorry, next time. So, let's see if I can Extend desktop mirror displays. Mirror displays. Oh, much better. Okay. So what's happening here? We see what's going on when I browse this website, our website. So I'll do just one intercept. So this is what happens. We are removing the coupon, okay, and then that's clean. Then we enter a random value, and then this controller will return us the updated value for our basket. In this case, is the same, because the coupon was not a valid one. So if you send a valid coupon, I'll show you in the code that this is valid. So our basket will get to 40. So this is the value that we are going to pay. And this is what we see. But looking at the code, that here it is. This is the code. It's not going to be too complex. Extend, display, mirror. Perfect. So let's look here. So this is the piece of code that deals with the basket. So we have this line where we set, it's just coded the basket total, and then if the coupon is a valid coupon, as this one, we are going to subtract the value of the coupon, 18.93, to the basket, and then we return the updated value. In this case, looking at this code, unless you already see what's wrong here, and there is something wrong already. So there is something wrong here. So what do you think will be the value of the basket if we play with this application? So, and now get back to your phone and tell me what do you think. Okay, nice. So I agree with many of you that somebody has to pay us. That's because we are doing this job. So, yeah. Is it coming on? There it is. Okay, so this is interesting. So 40, it may be. It can also be 21 and 07. It can even be any number less than 40. And I'm going to show you. And what is interesting, and this application is in Java, so there are the magic of Java behind it, but sometimes we can even get a fractional number with a long number of zeros, and that is because of rounding happening. Yeah. So now I'm trying to mirror displays. Oh, I need to fish this back. So now, time for the demo. So I'm going to use a tool, one of the plugin of Burp that is called Turbo Intruder. It is different than the intruder because it optimized to send a lot of requests at the same time. So it's possibly one of the best tools to play with this type of vulnerabilities. So what we are going to do, And how it works, you select the pattern you want to use as a placeholder, and then you say, okay, let me play with Turbo Intruder, and I wrote this little snippet of code that's similar to Python. So, but taking it easily, what's going on, we are going to send this request many times, passing a value here. So, and what the code does, it throws a lot of requests to the web server, and then it filters out 40. We know 40 is the right value, so we are interested in different values. So 40 is discarded in the final result. Let's see. So you need to fish it for it. Yeah, we had one case already. So I played a few times already. See, here you can see we sent 500 requests in this little time. And this is what the server returned us, 2107. That is because a race condition is in the code, and the value, the final value of our shopping cart, it gets subtracted twice. So let's see if we can see another few. Yeah. So in this case, yeah, still 21. If you keep playing, the more my machine is loaded, and my machine, as you can see, it looks like more a Christmas tree. So you may even get very low values. So, and when you get that number I was saying, very long decimals, because it gets into negatives, and then since it's an integer, it rounds it up. So now, okay, so I should take that away. So, okay. So here, we are back to our piece of code. So what's going on here? So let's assume we have two requests that by chance are happening together at the same time. So the first one is able to go over the if condition. But then there is a subtraction. So while the first thread is doing the subtraction, there is another thread that is using the same piece of code, and it stops at the if condition. So the yellow one knows that the basket is 58.93. Even the first one, they know that that's the value of the basket. Then the first thread goes on, subtracts the value of the coupon, and gets to the basket and return the final value. The other thread now that is going to do the subtraction will subtract the value from the basket, but the basket is now 40. So it subtracts again, and that's why we get 21.07. So this is what's going on, because we have, in this case, the problem is because of this variable here, basket total, that in the context of a Spring application, like this one, and sometimes with Java, because of the execution model of Java, there is not real multi-threading unless you are handling it. So in this case, the instance is sharing the same variable. So in the context of Spring, your method, your controller is locking resources inside it. So if you want to have such behavior, you need to implement your remediation inside your method, or you need to have a locked section that handles the common variable. So then this is what we used. So a bit of a summary in case you want to return back and see what we used. So in the end, in my repo, that you will have different Turbo Intruder scripts that you can play with if you want to test it or demonstrate somewhere. So the mitigations that can be applied in these situations are different, depending on if you're caring about performance, or if you're caring about security, safety, or if you want to strike a balance between the two. So as I noted here, in J2E, J2E does not implement thread management. So if you want to do that, don't do it yourself. As we were saying earlier, frameworks in this case is coming to and help to you. But as we were also saying, frameworks are too complex, so you may end up falling for the same pitfall of not knowing what the technology you are using does. Then there are options like manually handling the critical section. As I was saying, you have different options, and depending on the language. So this is not Java specific, the concept of critical section, but the remediation I'm explaining here are more Java specific, but you may find them in all the languages you are currently using. Golang is a little bit better into this context because it was designed with the idea of concurrency. So in Java, since Java 1.5, you can use this reentrant lock. That means that the same thread can refer to a lock sharing the same variable. So this is an approach. But still, now you may end up in deadlock if you forget to unlock your lock variable or your reference variable. Then you can use synchronized. Synchronized can be applied at different level in your class. The better in this case is to apply at method level so that, let's see if I'm referring, yes. So, yeah. The issue with this one is that even you will be losing your multi-threading behavior because in Java, if you apply in Java Spring, if you apply synchronized at method level, the synchronization happens at instance level. And your controller is just a bean, one only bean. So that means that all thread will be queuing on the same resource before being able to access. So yeah, this is something you need to consider. Yes, depending if you're fine if you have one user at a time. Yeah. And then, or you can implement your own semaphore. That is in Java. It's easy as long as you remember to release your semaphore. Otherwise, you will be starving your application. Then other mitigations that use what you can do based on your application. So in this case, we are talking about the framework we have. So you should consider the scope your application is applying to the different part of your application. As I was saying, a controller is a bean, is one bean. So you can consider to annotate your controller as being a singleton, but that means that doesn't work because you are sharing the same. So the problem is still there. You are not solving it. You are just sharing the same variable. So a valid option can be to apply the prototype annotation because it means that every instance returns a different value, so you're not sharing the same shared variables. So prototype seems to be a good one. Then other alternative, you can apply annotation related to the web application context. They are all good except the scope application. Scope application means every application shares the same scope. So since you have multiple users using the same application, you are going to have the same problem. So application in this case is not going to work. So then consider this is a little bit of a trick going back to the fact that you need to know the framework you are working with. This annotation behaves differently if you apply it at the type level or at the method level. So, and the difference is that where the locking is happening. So in this case, if you apply at method level, the locking is happening on the value returned from the method. So that means that since your method is returning always the same string object, you may end up falling back into the initial mistake. So this is just to say, whenever you decide to go for a specific mitigation or remediation, just look at the documentation, because many times it reserves surprises, or you may think you solved it, but rather that's not true. So then we reached the end. So if you have any question, I'm happy to reply if I know something, otherwise. No.
So what of this mitigation works if you scale vertically?
I think the best one, in my view, is the semaphore with the very limited critical section.
Because there is a solution already known from distributed computing.
Sorry?
There is a solution for this, of a good mitigation. It comes from distributed computing, and it's CQRS.
Oh, yes. Yeah, queuing, you mean like SQRS?
CQRS, the command response segregation.
Oh, okay, yes.
When you have a write side, where you just use a queue or some Kafka messaging. So you make it asynchronous, and you have a read side where you accept that your data may be not up to date.
Yes, that's also another one. Yes, yeah, that could be. Yes,
because you can do synchronization nicely within the JVM, but as soon as you have more than one JVM running the same application, you will not have those guarantees.
Yes, yeah, that's correct. Yeah, the messaging system outside, is a good mitigation to scale it vertically. Yes.
Any other questions, remarks?
Anyone who wants to buy from my shop?
Yeah. We have some coupons.
Coupons.
We can share. All right. Okay. Thank you. Thank you.
Thank you. Thank you.